Hello there, it's Jay here from Jay's Vintage Junk, and today this is a little bit of an impromptu video because I've just got back from work, and that was waiting for me on the doormat. Now, I haven't opened it obviously yet, as you can see the package isn't opened, but there's only one thing I've ordered recently from Bulgaria, and that is the replacement ULA for this thing. Now, on the order it did say to expect delivery between I think it was like the 7th or the 8th of this month and the 20th of this month, and it's the 5th today and that's arrived. So I thought I'd just do a quick video before I've got to shoot out again. We'll open this package up, see how well sent this is. We will open up the Oric, we will whip out, I have reassembled this just so I didn't lose anything from it, and I've put a 40 pin socket in for the ULA, because on this one the ULA was actually soldered to the board. But without further ado, let's open this package up and let's see how they have sent the ULA, and indeed have we got the right part. Apologise for my appearance, I've been doing rather a messy job and I haven't actually had a chance to clean up yet. But right, so we've got some bubble wrap, and possibly it's actually anti-static. Let's get inside this thing. It's held together with tape as well. Let's try and do this on camera. I've packed it quite well, I must admit, and hopefully this is anti-static bubble wrap. It's pink, and usually I think the pink stuff is. Right, well, let's get rid of that nasty anti-static that I pulled off. So we've got a sealer bag, a non-anti-static sealer bag I may add, which is quite likely to generate static, so that's not a good idea. But we can get inside it. Again, they've sellotaped this shut as well. There we go, that's some of it. Let's try and get in here. There we go, that's it. That's the sellotape off. So like I said, it's not good having it in just a plastic jiffy bag like that. At least they've gone to the trouble by the look of it. I mean, the anti-static bubble wrap's not bad. It's not static proof, as in it won't stop static going through it, but it won't generate static. These will, however, so that's not brilliant. But at least they seem to have stuck it in some anti-static foam. In fact, let's just see. I've got the meter set up here. I don't think you'll see this on trial, but let's just have a quick go. Is there any anti-static value at all for that? No. So that, although it's pink, I expect to get at least. Is that my part? Yeah, that's most of my probes touching. No, that is not really, and it's not conductive foam. Whether it has any other anti-static properties, I don't know, but it's not conductive foam, so that's not good for that poor chip, unfortunately. We can but see. But I don't like to find chips really shipped like that. It's not good. At the very least, it could have done with being on a piece of proper conductive foam, and then what I'd usually do is wrap some foil around it so it's absolutely protected. Then you could put it in a jiffy bag, it'd be okay. So we'll just have to see. Anyway, without further ado, let's get the Oric open. Let's get the old chip out. We'll stick that in and we'll see what we get. I'm not promising this is going to fix the Oric. We've not done anything else yet, but at least we can try. Like I say, I'm supposing it could still be that other IC. Is it IC22? It could still be that, but I'm suspecting it is the ULA. So if this ULA is indeed working, or at least if it's working if it's faulty and it's got a different fault on it to the one that the one I suspect that's faulty in here has, we may get a lock picture even if something else doesn't work. So we'll just have to see. Right, so that's all the screws out. Let's take the bottom off. We've got that in shot. There we go. So that's the fender there. That's what we need to take out. Let me find my favourite screwdriver for removing them. There should be something in here. No, that'll have to do. It's not the one I normally use, but it'll do. Let's just gently ease out the old chip. Come on, up you come. You got to be careful doing this. You don't want to apply too much force. You don't want to apply your force. If you can help it all from one side, it's a good idea to do what I'm doing here and go a little from one side and a little from the other side. I must admit I could have cleaned the pins up on this chip better, but I just wanted to shove it in for now because I knew I had to replace it. But anyway, that's the old ULA out. Let's take the new one out of the packaging. Let's have a look at it. And it does appear that that is a brand new IC. I can't see any marking on the pins where it's been in and out of sockets. So I think that is a branny. Let's insert it in the socket. Shit, nice and home. There we go. That's gone in. And let's just make sure that it is all sat the way it should be. It is. Okay, we'll stick that. I'm not going to throw that chip away because that'll be useful if I ever come to repair any Orics again and they're completely dead. I suspect a ULA fault. I can use that as a test ULA. See, we know what fault it produces. Hopefully, once we'll know after we fire this up anyway. If we know what video fault it produces, it's a good chip for testing purposes. I have a few Sinclair Spectrum ULAs that I keep about which are faulty for exactly that purpose, because you don't want to fry a good ULA on any computer, because all ULAs are getting scarce to get hold of. So it's a good idea to test first with one that you're not too concerned if it goes pop. Right, let's give this a quick test. I'm not going to screw the case back together. I'll just stick it like that so we can test. Let's get the video cable. Shove that in there. I will promise I will get on with that video about my little RGB switcher thing here. I've got all the bits to do another one. I just really haven't had the inclination to do it yet, because I'm going to make a little bit more effort than I normally do on that one. See, I want to make it something people could possibly follow. Most of my videos are just me rambling and fiddling with old computers, but that I think is something that other people might be able to use and be useful, so I will put a little bit more effort into the video on that. Let's switch the monitor on. Come on. Put it in the right mode. There we go. Put some power up the computer. Okay, now this is the moment of truth. What is it going to do? Let's see what you can see there. I think we will bring you up so you can see the screen. Okay, so we've got you on the screen there. We will power on and we'll see what it does. Okay, and it's exactly the same. Right, okay, now that's interesting. So that means it's probably not the ULA, unless this ULA's got exactly the same fault as this one, which seems unlikely. It looks like that fault is not related to the ULA. Which means it can only really be one other thing. Let's see if we can lift this up while it's... Oh no, we can't, because all the bits are through the holes in there. But that means it can only really be IC22, which is at fault, I think. Which is a bit of a pain, because I was struggling to find one of them. But hey ho, I think I'm on a search for that. It's a 74 series Logic IC. It's just not one that you come across very often. Right, well, I'm going to leave that at that, because it was literally, I was just doing this video just to see whether sticking that new ULA in would solve the problem or not, which it's not done. So on to another chapter with this one. I will endeavour to find IC22, which I think really can be the only other fault there, because we've isolated everything from the RGB light, from the composite side of it that drives the modulator. We've eliminated that. We've eliminated the ULA as the fault, hopefully. So the only other thing really is IC22. So we will get a replacement for IC22, and we will get back to this computer then. So I'll leave it here for now. So thanks for watching, and goodbye.